This is David, NR9V with AllScan with a build video of the AllScan ANH85. The ANH85-M USB radio interface and mounting plate is designed for Retevis RT85 and equivalent HTs, i.e. the Explorer QRZ1 or the TYT THUV88. There is no simpler or more cost-effective way to build a high-quality node for AllStar or any other radio over IP or data communications application. No batteries are used. The RT85 is used as a radio module only and is 100% powered by the ANH85-M with no separate power supply or chargers required. The ANH85-M integrates the URI 142 electronics onto a mounting plate PCB, enabling nodes to be built in minutes with excellent audio quality that is far superior to Shari SA818 and clear node type hotspots, while being dual band VHF-UHF, providing 1, 2, or 2.5 watts power output with simple front panel configurability right on the HT LCD and keypad. The ANH85-M is very compact, measuring only 3.5 inches wide by 3.8 inches high and about 1/4 inch thick. All needed cables are included, including a USB cable with ferrite and the 2.5 millimeter and 3.5 millimeter TRS cables. Version 1.1 of the ANH85-M adds a USB hub and serial port IC supporting PTT and COS from serial port control lines, RTS and CTS or DCD, in addition to the PTT and COS lines on the CM108 IC. HT serial programming is also supported. Let's go ahead and get started. First, we have a Dell 3040 mini PC, which are very low cost, highly reliable mini PCs that have been used for AllStar for years with great results. And when I get these in, I refurbish them, clean them up, check the battery, replace the RTC backup battery if it's low. So let's check the voltage on the battery. See, we've got 2.8 volts on the battery, and this is a battery from 2020, so about 6 years ago. So that's pretty good. 2.8 volts will actually be fine for another few years for backing up the real-time clock in the 3040. But if I was going to be shipping this out, I would put a new battery in there, and I've been wanting to show how I change out the batteries just so people can do that for themselves easier. The battery assembly with this little connector on it is pretty specialized and pretty hard to find, or if you do find them, they're charging like $10. But what you can do is just take off the little cable assembly here and then stick them right on a new battery. So take off this heat shrink. And then take off the solder tabs, which actually aren't soldered on there. They're just have a couple of little welds, a couple small spot welds, come right off the battery. And then These CR2032 batteries are very easy to find for $1 each. Take some electrical tape and we'll make sure these terminals are flat. They don't have to be perfect. If there's some irregularity to the surfaces, that would actually improve the contact reliability. And these terminals are only going to be carrying microamps of current, so it's not like they need to be super heavy duty or welded or soldered onto the battery. Make sure that the metal is not touching the outside, just the minus side of the battery there on the black wire. And you can see how I've got that down. And then the positive on the other side. And then a couple more wraps of the electrical tape around the battery to cover up any remaining metal. And we now have a brand new battery for the 3040, which took us about 2 minutes to put together for a grand total of $1. Take a square piece of foam. And put the battery back on the board. And then we'll just check the voltage again to make sure everything worked out. And we've got 3.307 volts. At that point we can put the cover back on. And then the next step is to mount the HT on here, and then at that point we will drill the holes to mount the ANH85 to the Dell. Could just use double-sided acrylic mounting tape to mount the PCB to the Dell 3040. This stuff works really well, but it doesn't really take much longer to just drill a couple of holes and use some screws, and the screws should be a better long-term solution, and those will also provide better grounding by connecting the PCB ground directly to the case ground of the computer, which will help further reduce any possible RFI that might be conducted in a USB cable. So now we'll mount the HT. So we've got two M2 by 20 millimeter screws with washers. We put in the two mounting holes here, and then we've got two 7 millimeter spacers that go on the front side of the board. And then we're going to take out these two screws from the bottom of the RT85. And then the RT85 just drops right onto the front of the ANH85-M. Flip it over and screw it down. And when you're screwing it, you want to hold the top of the HT so it's tight in that little notch that's cut out at the top of the PCB. This 2-inch wide notch that is designed to fit this top back part of the HT. So we've got that nice and tight in there. And we'll tighten it by hand until it's nice and tight, but we don't want to put too much pressure and strip anything. But these screw holes in the RT85 are pretty solid. I haven't stripped one yet. Okay, that's nice and tight. And then we'll use a zip tie at the top. It's a 4mm wide zip tie, 12-inch long by 4mm wide. These are rated for something like 50 pounds. And then I'll put the start the zip tie on the top right there so that this piece will be on the top right rather than at the back where it would be in the way of the 3040, or on the right where it would be in the way of the status LEDs. And we'll make sure before we tighten it down, we'll make sure that's pulled pretty solid so there's no slack at the back of the URI. And then do the final tightening. And you want to pull it pretty tight, maybe 20 pounds of pressure. And trim off the extra. And now we've got a very nice solid mounting with 2 screws at the bottom, and these spacers keep the HT at the optimum distance to where the battery contactor stays very tightly up against the battery terminals on the back of the radio. And then at the top, the zip tie keeps the radio tightly in that groove at the top of the URI PCB. At that point, we can put on the cables, but first let's drill the holes for the mounting screws. We only need 2 mounting screws with the Dell 3040, so we're going to put them through here and here. And this is what the node's going to look like. Power switch controls everything. There's no separate adapters required, just one adapter comes into the DC power in on the Dell 3040, and the 3040s will take anything from 5 to 14 volts, so you can run them directly off vehicle power. That is the newer versions. This 3040 was made in 2020. Pretty much all of the 3040s made in 2020 or later are the 12 volt versions, but those will actually run fine on 5 volts. If you happen to have a USB power pack, you can run the entire node on a USB power pack, or you can use the included AC adapter, or you can connect it directly to a 12 volt power supply with the 4.0 by 1.7 millimeter plug, which is a very standard low cost plug. It's easy to wire. You don't have to deal with the USB-C jack powering that our Pis have, which is much more of a hassle to get power from other vehicles or batteries or even USB power packs, because they have to have very specific voltage and power delivery compliance and all that, whereas the 3040s just take a straight 5 to 14 volt input. So the node will sit like this with the jacks on the left. So we've got Ethernet jack here, DC power in, USB from here to here, and we'll center that, and with a small drill bit, what size is this? That's about 2.5 millimeters. Make sure that everything's nicely centered. Yeah, that looks good. We're just going to drill through the plastic on the case, not all the way through the metal. Now I've got 2 holes drilled in through the plastic on the 3040. Now we'll pop the cover off again. Drill the holes through the inner metal part of the cover. And then we'll get rid of the burrs on the case with a larger size drill bit. Got some nice clean holes with no burrs. Everything all shot back and cleaned up. And now we can put the cables between the HT and the URI. And then I'll secure those with a zip tie. Cut off that. Okay, now I've got the two zip ties secured, so we can then screw on the back of the 3040. Okay, so we got the screws through the PC board, and we'll then put a couple of spacer washers so that the bottom of the 3040 is about half a millimeter or a millimeter back behind the PCB, which leaves a little room for the screws at the bottom and some of these different little pins that stick up a little bit. Pop that on there, and then two lock washers and the nuts. Get it a little bit tight on each side. Not tighten it all the way, we want to make sure it's straight. Now look at the bottom and straighten it out a little bit. Okay, everything's nice and tight. Take a look at the bottom, we can see that that's nice and level. And now we'll snap on the computer. And it's a very nice clean fit, and that's not going anywhere. The USB cable goes in. And the node is pretty much done. Just put a little mark on the volume control. Volume control should be set at about 9 o'clock, just a little bit under 9 o'clock. And then I put a little mark with a silver Sharpie. And last but not least, the antenna. So this makes for a very nice compact node. With the USB cable, it's about 5 inches wide, about 5.5 inches tall, not including the antenna, about 2 inches thick. Got detailed status LEDs here for the USB host status, ADC clip, which is an indication from AllStar that clipping was detected on the receive audio from the HT COS, PTT, and serial receive and transmit status LEDs. got COS destination. Normally for AllStar that'll be set to COS, but for other applications such as Zello or Echolink on Windows, you could set that to CTS or DCD, or for some digital mode apps that don't support the CM108, you can set that to CTS or DCD. And then PTT source should generally be set to PTT for AllStar, or it can be turned off or set to RTS for apps that don't support CM108 PTT. And then we've got our power switch here, which controls the radio power, and that can be turned off for some reason if you just wanted to turn the URI on but not the radio, or on, or you can set it to auto, and then when it's in auto, the ANH85-M has a circuit that will detect USB host activity, and when the status LED is blinking or the serial port DTR line is asserted, then if the switch is auto, then the power to the radio will be turned on. So at this point, I'll load AllStarLink on the 3040, enter the node number, and that's pretty much it. And then I'll also show you the HT programming, so rather than have to go into all the menu settings, it only takes a few seconds to load the settings into the HT from a Windows PC using the Retevis programming tool. Got the Retevis programming tool running on Windows 11. Plug in the USB cable to the URI. See, the radio comes on, status LED comes on, and then in the Retevis program, I'm going to open up file. I've got my RT85 settings file here, which is available on my website in the how-to guide for setting up full duplex HT nodes, which also applies to half duplex HT nodes. Now let's open the settings file, and then all I have to do is click on write, and you can see the progress bar. And now the settings have been written to the HT, and I didn't have to even touch any of the menu settings or go through anything on the keyboard. Exit that and unplug it, and we're done. This is a quick demo of an AllScan ANH85 half duplex AllStar node built using a Dell Weiss 3040, an AllScan ANH85-M URI mounting plate, and a Retevis RT85 HT. In the background, I've got the AllScan web app running. I'm scanning my favorites, and we'll try connecting to a couple of nodes.
By this time, but I got off to late start doing Uber, so I got home late, so it kind of shifted the plans of things a bit. So I just happened to turn the radio on and heard the tail end of it. All right, very good. Now we've still got more check-ins to get after I do the weather, so came in just at the right time. All right, Tom. Well, thank you for checking in. Have yourself a good evening and a good rest of your week. Again, I'll let the repeater reset because it's going to go a little bit. AC9H on net control. New rainfall amounts between a quarter and a half of an inch possible. Thursday, showers likely and possibly a thunderstorm before 1 p.m. Then a chance of showers and thunderstorms between 1 p.m. and 4 p.m. Then showers and possibly a thunderstorm after 4 p.m. High near 71, breezy, with a southeast wind 15 to 25, becoming south in the afternoon. Wind gusts as high as 40 miles per hour. Chance of precipitation is 80%. New rainfall amounts between a quarter and a half of an inch possible. Thursday night.
And let's do a quick parrot test. Test 1, 2.
Test 1, 2.
Turn off parrot mode. And power off the node.